Let's delve into the complexities of motor connections, specifically focusing on the situation described with the greenhouse motors from Israel. The core issue revolves around why a motor, intended for a Y-connected system, seemed to function correctly only when wired as if it were a delta-connected motor. This discrepancy likely points to an internal wiring error within the motor itself. To understand this, let's clarify the basics of three-phase power systems. In a 120/208Y three-phase system, the voltage from any phase to ground is 120 volts, and the voltage between any two phases, known as the line-to-line voltage, is 208 volts. A delta system with a line-to-line voltage of 208 volts also inherently has a 120-volt relationship to ground, although it's configured differently. The key difference lies in how the motor windings are internally connected. In a delta connection, the three windings are connected in a closed loop, forming a triangle. In a Y connection, one end of each of the three windings is connected to a common point, called the neutral point, resembling a star or a Y shape. The problem experienced with the greenhouse motors suggests that the internal wiring of these motors may have been inconsistent with the labeling. When the motors were initially wired according to the Y configuration diagram, they lacked sufficient torque to handle the shade curtain's load. This could occur if the voltage applied to each winding was not the appropriate level, or if the phase relationships were incorrect. By wiring the motor as if it were a delta-connected motor, the electrician effectively reconfigured the internal connections, potentially correcting the initial wiring error. In essence, the electrician may have inadvertently wired the motor in a Y configuration that aligned correctly with the 208-volt three-phase power supply. If the same situation were to arise with a motor manufactured in the United States, the result would be similar. If the internal wiring of the motor were erroneous, misapplication would result in either not operating at all, operating at a decreased output, or even damage to the windings of the motor. It's crucial to inspect the motor's nameplate and wiring diagram carefully to ensure the correct configuration for the supply voltage and intended application. If discrepancies arise, consulting with a qualified electrician or motor manufacturer is always advisable.